Hello, this time, let's make a simple aura effect using Helix Mesh. First, to create a helix-shaped curve, we are going to use 3ds Max. Click the perspective field and press Alt plus W to enlarge it. Next, click Helix to create it. Adjust the parameters in the lower right corner to make the helix of the desired shape. Next, we'll create a face along the created curve. Click Plane to create it. Create a plane of the desired size by adjusting the parameters in the lower right corner, and make the surface smooth using width segs. Now, let's make the plane according to the helix line. First, adjust the position of the plane to be at the origin. Unwrap the plane using UVW. Click Convert to Editable Poly. Next, click Path to Form. After clicking Pick Path, click the helix you created earlier. Use the Path to Form axis to find the appropriate coordinates. Adjust the parameters and move the plane according to the helix created previously. When the desired shape is created, press Collapse 2 to create the final mesh and merge them. Finally, remove the helix line that was made at the beginning and place the completed mesh to the origin. Click Export Selected in the File menu and save it. Now, create new Unreal Engine project and import your helix model. First, let's create a material to be applied to the helix mesh. After selecting the provided glow texture, in the Material window, while holding down T, click the left mouse button to create a texture sample. Create Multiply node. Next, create a particle color node which can receive color value in Niagara. Change the shading model to unlit and the blend mode to additive. Then check two-sided. Additive blend mode takes the pixel value of the material and adds it to the pixel value of the background, and the area with the color value will be displayed as bright, and the area with the black color will be displayed as transparent. And unlit shading model means only the emissive value is output, without lighting or shadowing. Checking two-sided is for expressing the material on the back side of the object as well. Look at the previously created helix model as a mesh preview. Select the provided T-caustic texture and put it in the texture. Create a multiply node and multiply it with the glow texture. To make the texture move according to the mesh, create a panner node. Connect the panner node to each texture UV. To move the texture in the X direction, enter -0.25 value in speed X. To control the texture movement through the Niagara module, create a dynamic parameter and connect it to the panner's time part. To prevent the texture from being connected, open the texture and set the X-axis tiling method of advanced as clamp. Lastly, connect T-side texture and multiply it with output to express the end of the texture naturally. Now, let's make a Niagara emitter using the created material. Since we will create an emitter using a mesh, we will delete the sprite renderer and create a mesh renderer. We will set the previously created mesh into meshes. To add a material to the mesh, click on Enable Material Overrides and set the helix material. Change the emitter state's life cycle mode to self to make the particles come out at the desired timing. To keep particles coming out at a specific speed, create a spawn rate, and then enter one to output only one particle at a time. To have time to randomly set the lifetime of the particle, change the lifetime mode to random in initialize particle and enter the desired range of values. Enter the desired mesh size in mesh attributes. Create an initial mesh orientation to make the mesh appear in the desired direction. To make the helix mesh lengthen in the Z direction as time goes by, create a scale mesh size and only the Z value increases the graph. To change the color of the particle, create a color and then change it to the desired color. Adjust the alpha value on both sides to look natural when particles appear and disappear. Create dynamic material parameters to move the texture by controlling the value of the dynamic parameter added to the previous material, and set the values of 0 and 1 as desired. Create Niagara systems. Right-click and click the emitter you just created in parent emitters. Duplicate the emitter created to make two particles that rotate in different directions. In initial mesh orientation, enter a Z value of 0.5. After that, if you check it, you can see that the two particles rotate in different directions. In order to make the particles appear with a time difference, we will give a loop delay value. If you place the Niagara system you just created on the level, you can check the result. Next, we'll create a glowing circle effect to be applied to the floor. First, create a material. And add the provided glow texture. Create multiply and particle color and connect them like the video. To make the particles translucent, change the blend mode to translucent and the shading model to unlit. Then check two-sided. Now, let's make a Niagara emitter using the created material. In the sprite renderer, we will put the material we just created in the material section. Create a spawn burst instantaneous and enter 1 so that only one particle is created. Change the sprite size mode to uniform and enter the desired size. Now we will create a color and change the color. Adjust the alpha value to make the color translucent a little bit. Create an aligned sprite to mesh orientation and enter a value so that the particle lies on the floor. In the sprite renderer, change the alignment to custom alignment and the facing mode to custom facing vector, in order for the user to directly specify the direction. Now, put the glow emitter we just made in the Niagara system. Now, let's make the particles that go up. Copy the glow material. Change the blend mode to additive and connect the nodes like the video. Now, let's make a Niagara emitter using the created material. In the sprite renderer, we will put the material we just created in the materials section. To create multiple particles, create a spawn rate and enter 20. To set the lifetime of the particle to random, in Initialize Particle, change the lifetime mode to random and enter the desired value. Change the sprite size mode to random uniform and enter the desired size. To make the particle appear in the shape of a cylinder, create a shape location and adjust the height and radius values. Create add velocity to make the particles rise. At this time, a warning message will appear, and it will disappear if you create solve forces and velocity. And set the Z value. Create a scale sprite size to make the size smaller as the particle rises, and adjust it through the curve value. To change the color of the particle, create a color and then change it to the desired color. Adjust the alpha value on both sides to look natural when particles appear and disappear. Put the emitter you just made into the Niagara system. To make a long rising particle, copy the rising glow particle emitter. Lower the spawn rate value to 10 and change the sprite size mode to random non-uniform. And the X value is small and the Y value is large. Change the height and radius values in shape location and also change the add velocity value. To make the X value small and the Y value large over time, change the scale sprite size to non-uniform curve and adjust it through the curve value. Change the color value. Finally, let's create the magic circle effect on the floor. Create a material using a magic circle texture just like you made a glow material. Now, let's make a Niagara emitter using the created material. In the sprite renderer, We will put the material we just created in the Material section. Create a spawn burst instantaneous and enter 1 so that only one particle is created. Change the sprite size mode to uniform and enter the desired size. Now we will create a color and change the color. Adjust the alpha value to make the color translucent. In the sprite renderer, change the alignment to custom alignment and the facing mode to custom facing vector in order for the user to directly specify the direction. Create an aligned sprite to mesh orientation and enter a value so that the particle lies on the floor. Finally, put the emitter you just made into the Niagara system. Now, let's check the Niagara system on the map. When you check the particle from above, you can see that the particles are lying down. To fix this, let's look at the Niagara system again. After clicking this emitter, in the sprite renderer, change the alignment to custom alignment and the facing mode to custom facing vector. Create a line sprite to mesh orientation and enter a value. If you check the particles on the level again, you can confirm that the particles do not change in any direction. Now, when you place Niagara in your level, you can see the Helix aura effect.